All right, in this lesson, we're going to talk about similar figures. Similar figures continue along with what we've been learning about ratios and proportions. So basically, similar figures have the same shape, but not necessarily the same size, okay? And when we talk about the same shape, that means that all of the angle measures have the same measure. All right, all the angle measures have the same measure, and the corresponding sides of the two figures are in the same relative position, and the angles are in the same relative position, and the corresponding sides all have corresponding ratios. Okay, they must all be corresponding. All right, or which means that they're all proportional. All right, so when we do that, it says which rectangle is similar to rectangle J. So we know that J, I'm going to do the big one first. Okay, so the 10 corresponds with the 12. All right, so we're going to say that's 10 to 12. And then that means that 4 corresponds with 5. Okay, 4 corresponds with 5. And if I cross multiply, 10 times 5 is 50. 12 times 4 is 48. So these two numbers here are not the same. So that means that rectangle L does not have corresponding sides with rectangle J. So it's not similar. Okay? So it's not similar. Let's try the small one. Okay? So once again, 10 goes with 5. 10 goes to 5. And 4 goes to 2. So when we cross multiply, 10 times 2 is 20. And 5 times 4 is 20. So those are the same. So it is a proportion. And so the small one is similar to rectangle J. So K is similar to rectangle J. All right, same thing with this. Okay, 8 corresponds with let's see, let's do 8 to 6. Okay, so 8 corresponds with 6, and 4 corresponds with 3. Cross multiply, 8 times 3 is 24. 6 times 4 is 24. So yes, rectangle B corresponds with rectangle A. Let's check about rectangle C. Rectangle C, 8 corresponds with 5, and 4 corresponds with 2. All right, now when I cross multiply that, 8 times 2 is 16. 5 times 4 is 20. So no, that is not a similar rectangle to A. All right. All right. So here I have two triangles, and with rectangles it's easy because the sides are all the angles are all 90 degrees, and the sides it's easy to keep track of what the corresponding sides are. In triangles, sometimes the triangles can flip around and stuff. So if we're doing this, we notice that, first of all, we notice that 35 is here, is on the bottom right. Here, 35 is on the bottom left. Okay, so that means the triangle is flipped around. So we have to be careful with what we're saying are corresponding sides. So if we look here, 8 here is between the 50 degree and the 95 degree. That's right in here. Okay. Over here between the 50 and the 95 is 12. So that means that 8 corresponds with 12, and 16, the bottom here, is between 50 and 35, 50 and 35. So 16 corresponds with 24. Okay? When I cross multiply, 8 times 24, I end up with 192. And 12 times 16, I also end up with 192. So yes, these two triangles are similar, even though they are, turned, oriented different ways. You just have to be careful when you do that, to make sure that you pair up your corresponding sides, right? So a box is 16 inches long and 12 inches wide. What's its length to width ratio? Length to width, okay? So I'm going to do length to width. Length is 16 and width is 12, and then I'm just going to reduce it down, either do it manually or put it in your calculator, and we end up that 4 goes into both of them. 16 divided by 4 is 4, 12 divided by 4 is 3, so we end up with a 4:3 ratio, length to width ratio. All right? A painting that is 40 inches long and 56 inches wide is to be scaled to 10 inches long to be displayed on a poster. How wide, this is what we're looking for, how wide should the painting be on the posters for the two pictures to be similar? So we say 40 inches long and 10 inches long are the corresponding sides. Okay, so we have 40 to 10 is equal to, 56 inches wide, 56 to x, right? So we're going to say 40 times x is equal to 10 times 56. When we reduce that or simplify it, 10 times 56 is 560 divided by 40. Okay, so x is equal to 560 divided by 40 is equal to 14. Okay, all right. So it should be 14 inches wide. Okay, 14 inches. Make sure that you put in your units of measure. All right. A t-shirt designer includes an isosceles triangle with side lengths. Okay, the side lengths are 4.5 and 4.5 and 6. So the two congruent side lengths are the 4.5 and 4.5, right? Okay, and the base would be 6. An advertisement shows an enlarged version of the triangle with two sides that are each 3 feet long. Okay, so the two sides are 3 feet long. And what's the length of the third side, or the base of the advertisement? So we have that the side lengths, the two sides are 4.5, and they relate to the 4.5 inches, okay, to 3 feet, okay. And we know that this in the t-shirt, it's 6 inches. And we want to find how many feet it will be on the advertisement. How many feet it'll be on the advertisement, not inches. Okay. Okay, so we cross multiply. We have 4.5 times x is equal to 3 times 6. Okay. 4.5 times x is equal to 18 divided by 4.5. So x is equal to whatever 18 divided by 4.5 is, okay? 18 divided by 4.5 is equal to 4, All right. All right. That is it for this lesson. So go ahead and make sure you've got your notes written down for the on the front page. Make sure you ask any questions if you have any. We'll talk to y'all later on.